Okay, this is an introductory lesson on the periodic table of elements. We've already learned about classification of matter and how pure substances can be either elements or compounds. So that word elements is really referring to possibly 118, here you go, 118 elements that we know of to exist. And you'll see number 1 up here is hydrogen, read across to number 2, helium, 3, 4, and so on to Ne, which is neon, and we keep reading across the rows, which we call periods, across the rows of the periodic table. 55, 56, you'll notice 57, we jog down here to the lanthanide series, and after 71, we're back up in this 6th row, and then we continue in the 7th row, come down here following the number to 103, back up to 104, and all the way across to 118. So 118 elements arranged according to their properties and other patterns in their atomic structure. We see they are arranged in columns and rows. So this is an introductory video to familiarize yourself with this periodic table of elements. All right, so when you look at a symbol, element symbol here, first you're going to notice that the very first letter of the symbol is always capital letter. If there is a second letter in the symbol, that it's lowercase. And chemistry is pretty picky about that, so try to always write your symbols with a capital letter first, and if there's a second letter in the symbol, lowercase. This way, every capital letter in a formula tells you that a new element is present. So, to understand we'll just what these numbers represent, we'll just look at carbon here, and you can see that, I'll just box this up and move it on up here for our representation here. So, this number up top, right here, this 6 is called the atomic number, and that'll be significant in terms of atomic structure for us. This decimal value here is called the atomic mass, so this is the average mass of a carbon atom. Here is the actual symbol of the element, and you'll see this spelling here says carbon, so here's where we see the actual name of the element. So this is a key to help you interpret the information that's in the boxes. You can ignore this 4A here. I will speak further about the notation at the top of each column there. Okay, so that's so you can understand what's happening inside each box. All right, so a comment then that we can fill in the blank up here. Elements are arranged on the periodic table according to increasing atomic number. So you'll see that, as I already pointed out, right, the numbers increase from 1 to 118 as you read across. Okay, now there are 7 rows, which we said these rows are called periods. So I'll draw an arrow, right? This is period 1. Period 1 includes hydrogen and helium, H and He. And then period 2 includes the elements from Li all the way across to Ne. And so on. Period 3, period 4, 5, 6, and 7. Recognizing this lanthanide and actinide series that these come in period 6 and 7. Again, follow the atomic number to see when to jog down here. So there are 7 periods. These are the rows on the periodic table. Now, what about the columns? Well, we can label the columns, and they've actually been numbered here already, right? See 1, 2, 3, and so on, all the way to 18. So there's the group numbers. That's what we call the columns in the periodic table. These are called groups. So group 12 has the symbols Zn, Cd, Hg, and Cen. We keep just going to circle these so that you can take note that there are 18 groups, okay? 18 groups in the periodic table. All right, What's significant about those groups? Well, elements that are in the same group, okay, which is also can also be described as a particular chemical family, which I'll explain in a minute. They have similar physical and chemical properties. All right, similar physical or chemical properties. That means these elements that are showing up here in group 2 all have similar physical and chemical properties. These elements here in group 17 have similar physical and chemical properties. And so it's that way for every column, for every group in the periodic table. Now, there's a significantly important feature of the table that isn't well marked on this particular one. So I'm just going to create this staircase here where I started on the side of the element with symbol B, which is boron. Okay, so what I've done is zigzag down the periodic table here. And that zigzag is very important. I'm going to set up a sample zigzag here to say that the metals are found on the left side of the zigzag. Actually, I'm going to change the color there just so that we can pay attention to the difference here. What can we say about metals in terms of properties? Well, they're shiny, malleable. If you go back to your physical properties, that'll be familiar. Ductile solids, all except for mercury. Mercury right here is the only metal that is a liquid. All the rest of the metals are solids. And what else can we say about them? That they conduct heat and electricity. So that's very characteristic of metals. So you can see based on the location of the staircase that most of the elements on the periodic table are metals. On the right side of the staircase over here, that's where we find nonmetals. And what can we say in general about the nonmetals? Well, there are a lot of gases, so they're mostly gases. There is one liquid, that's bromine right here. Mercury and bromine are the only two elements that are liquids at room temperature. So most of these nonmetals are gases. If they are solids, they're going to be dull, not shiny. So they're dull solids. Okay, and they are not conductive. So really the opposite to those shiny conductive solids that we saw for metals. Now, what happens if an element is on the border? So for example, boron, right, sitting here, or silicon, or Ge, or As, right, as we move down. So these particular elements on the staircase are called metalloids. And metalloids have properties of both metals and nonmetals. All right, so we have metalloids. Now, I purposely did not include aluminum right here sitting under boron because aluminum actually is a shiny, malleable, ductile solid that conducts heat and electricity. So aluminum, even though it's on the staircase here, just below this here, aluminum has only properties of metals, therefore aluminum is considered a metal. Now, about the rest of these elements here that we said were all metals, I will draw your attention to hydrogen here. Hydrogen over on the left side of the staircase is actually a non-metal. Okay, so we'll just be aware of that. It's over here because of some common structural features, but it is actually a non-metal, not a metal. So everything else here, all metals, okay, and non-metals on the right side. Okay, so we can further classify the metals on the periodic table by their particular family name. So I'm just going to draw your attention here to the alkali metals. Alkali metals are very soft, and by the way, since hydrogen is a non-metal, right, lithium, this Li is the first alkali metal. So here we go down group 1. In these alkali metals, these are soft, shiny solids, and they are incredibly reactive. They are the most reactive metals. So group 1 contains the family of the alkali metals. So remember, up here we said that elements in the same group or family have similar properties. So there's the alkali metals, right? In group 1, they're all soft, shiny solids, and they are the most reactive metals on the periodic table. Okay, now what about group 2 here? Well, group 2, these are this family. I'll just write their information over here. They are called the alkaline earth metals. So alkaline earth metals are themselves less dense solids as a group, and they are still very reactive. They're not the most reactive metals, but they're still very reactive. The section in the middle of the periodic table here, so groups 3 to 12, these are called the transition metals. And transition metals are more dense, so these are dense solids. Okay, and in terms of reactivity, they're actually less reactive metals. So we do get the most reactive metals over here on the alkali metals in group 1. Then group 2 is still very reactive, not quite as reactive as group 1, but still very reactive. Then when we move into here, the metals get less reactive. So in terms of families, you're responsible for the alkali metals, the alkaline earth metals in group 2, knowing the properties and location of the transition metals. And then we move over into the non-metal section. And you'll see here in group 17, we have the halogens. What can we say about the halogens? Well, these two are gases, fluorine and chlorine. Bromine's a liquid, and then we have iodine as a solid moving down the group. These are very reactive. So these are the most reactive non-metals. Okay, and then last group here is the noble gases. So group 18 here, this family is referred to as the noble gases. And these noble gases are very stable. We'll learn later why that is when we look at atomic structure. And because they're so stable, right, it's pretty safe to put helium in your balloon, all right, as opposed to hydrogen gas. That would be very flammable. But helium, nope, helium's very stable. So we say that these gases are inert, or another term for that, unreactive. So due to their stability, they are very unreactive. Okay, so this is an introductory lesson on the periodic table. You're responsible to know this information, that elements are arranged according to increasing atomic number. And when you look at a periodic table, you should be able to track the atomic number. Look in the corner of the box here and notice that they're all arranged, right, increasing, right, 11, 12, 13, 14, 15, 16, as you read across, right, 19, 20, 21. Elements are arranged, all 118, according to increasing atomic number. Okay, there are 7 periods, so 7 rows in the periodic table and 18 groups. There's group 18. Family names and properties for groups 1, 2, the transition metals, group 17, the halogens, and group 18, the noble gases. And maybe as a final point there, we can indicate the group number, the alkali metals group 1, the alkaline earth group 2, the transition metals run groups 3 to 12, the halogens are group 17, and the noble gases are group 18. Okay, as well, we reviewed where you find metals, nonmetals, and metalloids on the periodic table and their general properties.